Hello, everyone, and welcome to General Chemistry. So today we're going to start with a rather broad question, which is kind of important for the rest of the semester. What is chemistry? So chemistry is a really important central science. So one of the places I often like starting when describing chemistry is Richard Feynman, who is known as the father of modern physics, really revolutionized how how physics was taught. And one of the ways he'd always start his classes by asking this single question: if all scientific knowledge were to be destroyed and only one sentence was to be passed on to the next generation, what statement would contain the most information in the fewest words? So essentially, what's a central idea that you could use to rebuild all of science as efficiently as possible? And his proposed answer, and I tend to with it, is this idea that all things are made of atoms, which are just little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling each other once being squeezed when being squeezed upon. And what he essentially proposed here is chemistry, because chemistry is this idea of studying matter and specifically this motion of atoms. So throughout the course of this semester, we're going to be focusing a lot on the behavior of atoms, very simple functions, uh, how they can gather into molecules, which will have specific properties, which we can model, and how they can interchange to undergo chemical reactions. And chemical reactions can help us build any substance imaginable. So chemistry really is so important here. And one of the important things that I love about chemistry is that it tends to be the single scientific discipline that bridges all of the other scientific disciplines. So it's a way to interact this idea of atomic physics, which Feynman proposed, with kind of this everyday objects. So this includes things like biology, geology, weather, pharmacology, cuisine, cooking. All of this tends to tie into chemistry. And as a result, chemistry is often referred to as the central science because it's the scientific discipline that links all of the other applications. So it doesn't matter what science you choose to do, you need to know chemistry in order to be completed. Way I often like referring to this is if you can see it, touch it, or smell it, it's chemical in nature. So when we're going to be talking about chemical properties, it's going to be things like um, what does it look like? How does it interact with light? What's what's its mass, its hardness? These are related to touch. And if you can smell it, what you're smelling is little molecular particles or chemicals that have been released from a substance. So everything is chemistry. And this is important to keep in mind with this modern idea of trying to be chemical free, which is just a way of saying we want to have lower amounts of synthetic materials, because it turns out that everything is chemical free. If you eat it, it's chemicals. So you're going to be eating chemicals no matter what. Now, knowing what kind of chemicals you're eating can be much more important. And it's this nuance that I'm going to try and emphasize as we go along. So our goal as chemists, or just as chemistry students, is to understand how all of these different materials interact. How can I go from, say, atomic and molecular species to these things we tend to care about? Can I see it? Can I touch it? Can I smell it? Is it safe to eat? And for this, you do need to have a very basic understanding of chemistry. So one of the other things that I do like to emphasize with the importance of chemistry is its importance is so ingrained that when we tend to talk about eras of man, they tend to have almost always been defined by some sort of chemical development or some sort of improved knowledge of chemistry. For example, when we went to the Stone Age to the Bronze Age, It's because we learned basic metallurgy. We could make bronze, which is a chemical or metallurgical process. And the same happened when we went from bronze to Iron Age. Because in order to go from making bronze to iron, you have to work at much higher temperatures. You have to have a much better understanding of how to work with metal ores. These are chemical processes. And in the modern era, this still holds is when we went to the steam age, it's mastering a very important set of chemical processes. Most namely combustion and a good understanding of gases. So both this semester and more specifically next semester, we'll talk about a lot of the fundamental knowledge that made the steam age possible. But this keeps being the case, which is the atomic age, which is trying to couple the understanding of atomic nuclei with comedically steam power. It's mixing these two um, branches of chemistry together, which brings us to a very important point is that as you're starting to get the idea of chemistry is a really big field. And as such, we tend to subdivide chemistry into subdisciplines. So each one tends to look at the world a little um, a little bit differently. For example, if you're looking at organic chemistry, this is understanding uh, materials that are rich in carbon, which tend to dominate in things like understanding organic processes like how a body works. Interestingly enough, it also tends to work with dead organic tissue, most famously coal and oil. Petrochemistry, or working with oil products or petrochemicals, tends to also be organic. Things like inorganic chemistry tends to be defined of does it have something that isn't the basic building blocks of life? So does it does it make use of metals, which we'll talk about a little bit this semester. And we also have biochemistry, which is specific which can be thought of as a specific branch of organic chemistry, where we're looking at biochemical pathways. So chemistry as it works inside um, living tissue. And it is worth noting these three branches, organic, inorganic, and biochemistry, tend to be defined about by the system that they examine and look at. However, there's two other subdisciplines, analytical chemistry and physical chemistry, which focus a lot more on how you look at a system. Analytical chemistry is highly dependent on quantifying what you're looking at, measuring how much, exactly what's there, so making precise measurements. Physical chemistry, which is the branch that I belong to, is kind of the why of chemistry. If you want to know why something works, if you keep asking why, here we're looking at physical chemistry. So if you ever have questions of why, I might not be able to answer them, but I'll do my best to help you along the pathway because I love asking why myself. Now, one of the reasons I like to emphasize this is because when we are in general chemistry, what we're doing is we're essentially just dipping our toes into all of these five disciplines. So we're going to be covering very basics of organic, inorganic, and biochemical systems and giving a basic primer into making precise measurements and understanding how things work. But I do want to emphasize that general chemistry is just giving you a basic understanding so you can dig deeper into any of these other topics. And if you stay in chemistry, you'll look at some of the, you'll have classes devoted to each of these subdisciplines. If you decide to go into another discipline, well, general chemistry is essentially giving you the primer so you have a basic understanding of how these systems work. And if you need to talk to a chemist, you at least will share the same language. So next time, we're going to be digging a little bit more into some of the into how science actually works as we talk about the scientific method. Until then, take care.